As a continuation of the previous lecture, we will do some more problems on convolution. So next problem is compute the Fourier transform of convolution of the function f of x equal to e raised to minus mod x and g of x equal to e raised to minus 3 mod x. So here the functions are given as e raised to minus mod x and e raised to minus 3 mod x. So first we write the convolution theorem that is given by f of f star g is equal to root 2 pi Fourier transform of fx into Fourier transform of g of x. So first we have to find the Fourier transform of f of x. So by definition, Fourier transform of f of x is 1 by root 2 pi integral minus infinity to plus infinity f of x e raised to minus I omega x dx. The function f of x is e raised to minus mod x. So e raised to minus mod x. Since we cannot solve this directly, we use by expanding the function. We know that e raised to minus I omega x is cos omega x minus I sin omega x. So and we separate the integral as then next step we separate the integrals, that is integral minus infinity to infinity e raised to minus mod x cos omega x dx minus I is a constant, we can take it outside, I into integral minus infinity to infinity e raised to minus mod x sin omega x dx. Since here the integral is minus to plus integral, we can check whether the function is even or odd. If the function is odd, the answer is 0. When the function is even, it is 2 times 0 to infinity. Here the exponential term is here is x term is mod x. So this completely exponential term is an even function, and we know that cos is an even function. So even into even is again even. Then minus I into here exponential term is a minus mod x. So this term is even. Sin is odd. So this is odd. Sin into odd is, or even into odd is odd. So this is completely an odd function. So this integral value is 0. This is an even function. So this integral value is 2 times 0 to infinity e raised to minus cos omega x dx. Now we can apply the reduction formula of exponential, that is e raised to ax cos bx dx is e raised to ax by a square plus b square into a cos bx plus b sin bx. Here a is minus 1, b is omega. So it becomes e raised to minus x by minus 1 the whole square plus omega square minus cos omega x plus omega sin omega x. Now we can apply the upper limit infinity. We know that e raised to minus infinity is 0. Now we can apply the lower limit 0. So it becomes e raised 0 by 1 plus omega square minus cos 0 plus omega sin 0. And we know that sin 0 is 0 and cos 0 is 1. This minus minus plus answer is 2 by root 2 pi 1 by 1 plus omega square. 1 root 2 will be cancelled in the numerator. So answer is root 2 by pi 1 by 1 plus omega square. Similarly, we can find the Fourier transform of the second function, that is e raised to minus 3x. We can see that only the change is minus mod x is changed to minus 3 mod x. So first we write the formula, that is Fourier transform of g of x is 1 by root 2 pi integral minus infinity infinity g of x e raised to minus omega x dx. Here the function is e raised to minus 3 mod x e raised to minus I omega x dx. Then we expand this term as cos omega x minus I sin omega x, and we separate the integral. So first integral is minus infinity plus infinity e raised to minus 3 mod x cos omega x dx minus I into e raised to minus 3 mod x sin omega x dx. As told earlier, this is an even function, cos and even, so completely even. This is even and odd, so it is odd. So this one 0 and this one 2 times 0 to infinity. And here applying the reduction formula, here a is minus 3 and b is omega. So become e raised to ax plus x by a square plus b square into a cos bx plus b sin bx. And applying the upper limit infinity, this is 0 and lower limit 0, it become e raised 0 by 9 by omega square plus minus 3 cos 0 plus omega sin 0. And sin 0 0 and cos 0 1, and this minus minus plus, so the answer become root 2 by pi 3 by 9 plus omega square. So the by convolution theorem, Fourier transform of f star g is root 2 pi into f of fx into f of g of x. Now substitute the value of Fourier transform of f of x and Fourier transform of g of x, and by simplifying, and we get the answer 6 root 2 by root pi 1 by 1 plus omega square into 9 plus omega square. Next problem, compute the Fourier transform of the convolution of the function f of x is 3x from 0 to 3 and g of x is x by pi from 0 to pi. So first we write the convolution theorem, that is f of f star g is root 2 pi f of x into f of g of x. So f of fx is 1 by root 2 pi integral minus infinity to infinity f of x e raised to minus I omega x dx. The function is 3x e raised to minus, and limit changes 0 to 3. Now 3 is a constant, we can take it outside, then apply integration by parts. First term into integral of second, that is integral of this one is e raised to minus I omega x by minus I omega minus derivative of this one into integral of this one. That is again integral value is e raised to minus I omega x by minus I omega. There is already a minus I omega, so this one becomes square 0 to 3. Now apply the upper limit 3. So it becomes minus 3 raised to minus 3 omega by I omega. This here it is minus I square. We know that I square is minus 1. So minus I square means minus I into minus I. So it becomes minus 1. So minus minus this one plus 1 e raised to minus 3 I omega by omega square. And applying the lower limit 0, it become this one becomes 0 and this one become this minus minus there is a minus sign, already minus sign, this one plus the lower limit minus, it is minus e raised 0 by omega square. So simplifying we get the answer 3 by root 2 pi minus 3 raised to minus 3 I omega by I omega plus e raised to minus 3 omega by omega square minus 1 by omega square. Similarly, we can find the Fourier transform of the next function f of g of x, that is 1 by root 2 pi integral 0 to pi x by pi e raised to minus I omega x dx. It also 1 by pi is a constant, we can take it outside. Then apply integration by parts. First term in integral of second minus derivative of this one, the integral of second, and apply the upper limit pi and lower limit 0. And simplifying, we get the answer as 1 by pi root 2 pi minus pi e raised to I minus I omega pi by I omega plus e raised to minus I omega pi by omega square minus 1 by omega square. Then by convolution theorem, f of f star g is equal to f of root 2 pi into Fourier function of f of x into Fourier transform function of g of x. So this is the answer. Now we will do one more problem, that is find f of f star g is equal to where f of x is 1 by 2 from 0 to pi and g of x is pi by 2 from 0 to pi. So first write the convolution theorem, that is f of f star g is root 2 pi f of x into g of g of x. Now by definition of the Fourier transform, f of x is equal to 1 by root 2 pi integral. Here the limit changes from 0 to pi and the corresponding function is 1 by 2 raised to minus I omega x dx. 1 by 2 is a constant, we can take it outside. Then integral of e raised to minus I omega x is e raised to minus I omega x divided by minus I omega, limit from 0 to pi. First apply the upper limit pi. We can take the this term 1 by minus I omega outside. Now apply the upper limit pi, so it becomes e raised to minus I omega pi minus lower limit 0 e raised to 0. And e raised 0 is 1, so answer become f of x equal to minus, this is minus 1 by 2 I omega root 2 pi e raised to minus I omega pi minus 1. Similarly, we can find the second term. Fourier transform of g of x, and the function is pi by 2. So we can write the answer from the above. The above one is 1 by 2. So multiply a term. So we get the answer, multiply the answer by a pi term. So it is pi by 2 root 2 pi minus 1 by I omega e raised to minus I omega minus 1. So by the convolution theorem, f of f star g is equal to multiplying the Fourier root 2 pi into Fourier transform of f of x into Fourier transform of g of x. So answer is minus root pi by 2 e raised to minus I omega pi minus 1 whole square by omega square. So there are some problems from convolution theorem. That is first one, cos x function f of x is cos x. Limit from mod x less than or equal to pi by 2 means x varies from minus pi by 2 to plus pi by 2. And g of x is pi by 2 sin x. Mod x less than or equal to pi by 2 means x varies from minus pi by 2 to plus pi by 2. Then cos x from 0 to 1, function is f of x is cos x, and g of x is x square by 2 pi 0 to pi. So this is the last topic of our fifth module, that is the convolution theorem. The problems are this convolution theorem is very simple. Just learn the statement and just find the Fourier transform of the corresponding function and multiply the answer into root 2 pi. So thank you.